Welcome, everyone. We are so excited to see such an amazing turnout today for our relaunch of Dagster Deep Dives. I am joined by Colton, who is going to be your host for today's event. We're going to give everyone a little bit to join. We're right at the top of the hour. We'll have Colton get started maybe two or three past. But in the meantime, while we're waiting for our peers to join, if you'd like, please feel free to drop into chat where you're dialing in from today. I'm dialing in from Houston, Texas. Where are you dialing in from, Colton?
Yeah, I'm just outside of Washington, D.C. I just moved to Alexandria.
Awesome. Awesome. And for those of you that have just joined within the past minute, we're giving our peers a couple more minutes to join, and then Colton will get started with this Dagster deep dive. If you have questions, please feel free to put them in the chat. We also have a Q&A section that you can put them in, and we'll be asking some questions via a poll and a quiz throughout the event.
Oh, apparently chat is disabled at the moment.
Ooh, I'm looking, I see that. Okay, but Q&A is working. Let me see if I can fix that. That's a great call out. Thank you.
And this is being recorded for those asking. We'll make it available after the webinar.
All right, so all right. Um, so the chat function is unfortunately disabled. But any questions that you have, please put them in the Q&A section, and myself or Colton will answer those as we go. Or if we have some time at the end, we'll be able to answer those questions during the Q&A portion. I'd love for us to get started. We've got about 117 people joining us today, Colton. Are you ready?
Yeah, let's go.
Let's do it.
All right, as Sarah mentioned, I'm Colton Padden. I'm a developer advocate here at Dagster Labs. And today we're going to be doing a deep dive on data quality and how to build a reliable data platform. As an overview of what we're going to be talking about, first we're going to talk about what is data quality, why is it important. Then we're going to talk through 6 dimensions of data quality that you can use to build rules for data validation. We're going to talk about some popular data validation frameworks. Then we're going to dig into some code and show you how you can implement these kinds of data validations in Dagster. And then finally, we're going to talk about how to support data quality standards in your organization. So first things first, what is data quality? Data quality is an indicator to determine if data is suitable to be used in decision making. So this can be business decisions, this can be academic research, and really just in general, finding insights within your data. You want to have high quality so that you can ensure that the data is sufficient for use in this decision making. As the Practitioner's Guide to Data Quality Improvement puts it, data is used to both run and improve the ways that the organization achieves their business objectives. And data quality ensures that data is of sufficient quality to meet the business needs. So again, as business need to make decisions, data is gold for data-driven decisions, and you need to make sure it's high quality so that you have confidence in it. So what are these kinds of decisions? It could be product development feature prioritization. So you want to have a good understanding of people using your products, what features to prioritize. It could be risk assessment and fraud detection. If you don't have high data quality and you're trying to perform fraud detection on that data, you don't have any confidence as to whether or not you're actually detecting any fraud. It could be understanding your customer segments in marketing campaigns. And also, it's a lot of operational efficiency in these business decisions and how your business operates internally. For example, the data engineers on this call probably understand that if you're working with poor data quality, the effort is a lot more significant, and there's a lot of churn in that engineering. Another big one is the financial impact. So Gartner actually found that it is estimated that poor data quality can cost an organization $12.9 million a year on average. And now that's an average of big companies, small companies, but I think it's safe to say that there is a pretty significant financial impact if you're not enforcing high quality data standards for your organization. And then the most important one in my mind is trust. If you aren't sure that your data is accurate and you don't have high data quality, it really kind of echoes throughout the rest of the company. So by having high quality data, you can form trust among stakeholders, employees, customers, partners, really everybody. When you have a lot of evidence in your data for the decisions you're making, you also establish trust within your company. So that's what it is and why it's important. But let's start talking about how you can actually kind of promote high quality data in your company and in your data pipelines. So we're going to go through 6 dimensions of data quality. And these dimensions can be used to start to build rules that you would then enforce on your data sets. So the first one we're going to talk about is timeliness. And this is just that data is ready within a certain time frame. So as an example, you can imagine you're getting a report on an S3 bucket every week, and then it suddenly stops appearing. You want to ensure that that data is present and fresh. Another example is if you're building dashboards and like at 9 a.m. every morning, the business team goes in and looks at these dashboards. You want to ensure that the data is up to date and fresh and is timely. And later in this presentation, we'll talk about Dagster's Freshness Checks as a way to enforce this. And I think it's a really cool feature and you'll find it interesting. Next one is completeness. And this is that data is populated in both the attributes and the records. So this could be row level, like an entire row is missing from a data set, or it could just be that some attributes are missing. For example, say you have like customer records in a database table, and there's a first name, last name, and email address column, and that email address is missing. This could result in skewed analysis. And then another example, say you have transactional data where you have these transactions between 2 parties, say a record is lost, you no longer have an accurate representation of these transactions. And like if you're keeping a ledger of these balances, it'll no longer be accurate. So ensuring completeness is really important in your data set. Number 3 on these dimensions is accuracy. And in my experience, this is one of the hardest ones to enforce because the data is present, it's just not accurate. So you could have categorical inaccuracies. For example, say you have a medical patient database and they have allergies. Like down here in this table, we have Augustus Gloop is allergic to chocolate, which is not factually correct. So there is data there. So it's hard to validate that it is not accurate. So typically what you would want to do in this scenario is you have multiple data sets and you kind of corroborate the truth from that, or you have a source of truth that you can reference. Another form of inaccuracy is numerical inaccuracy. And again, this is a pretty tough one to find, but you could imagine having like a ride-sharing app GPS location, and the driver's location is off by 100 meters at all times. Something you could possibly do is like use rider location as well, and kind of reference that and the driver location together to try to figure out whether or not it's accurate. But it's a very difficult thing to enforce. All right. Number 4, we have validity. And this is kind of similar to accuracy, but it's that categorical values conform to what they are expected to be. The difference with inaccuracy is some of these fields are like open-ended, not necessarily categorical, or it is a correct category value. It's just not the correct one. That would be inaccuracy. But validity is, for example, say you have a bank that has customer accounts with a type field of either checkings or savings, and then one was entered as loan. This is categorically not correct data, and it is not valid. And then in this field of dimensions is also the structure or the format of the data. And a really common example of this is email addresses. You would expect them to conform to like the regular expression that matches an email address. And one thing to note here is we're looking at all this kind of from the lens of the data platform owner and the data engineer, but this data quality enforcement really needs to happen at all stages of the data lifecycle. So on your application, like your client side should have validation, the backend should have validation. Then when you're like replicating this data from a Postgres database, it should have validation. It kind of should be enforced throughout everything to have full confidence in the data. All right, number 5, we have consistency. And this is that data is aligned across systems and sources. I have 2 examples for this one. One is replication of a Postgres table to a Databricks Delta Live table. If that data is incorrectly replicated, say you have written custom logic for ingesting CDC events or something, and you get duplicate rows or just you're missing data, you don't have consistency between those data sets. This one actually comes up quite a lot when building replication systems and data pipelines, so it's a really good thing to enforce. And then the second example I have is there's a cryptocurrency exchange that allows transactions on their exchange, and they have an internal ledger that keeps track of like transfer of money. That needs to match what is visible on the publicly visible blockchain. And incorrect balances can cause transactional errors, and auditing will fail and things like that. So it's just alignment across systems. All right, number 6. Number 6 is uniqueness. And this is that data is free of duplicate values where you wouldn't expect a duplicate value. Just really quick, somebody asked if the slides will be available, and I will be sharing the PDF after. Yeah. Uniqueness. The example here is, say you have an online retailer that has products, and you have this SKU, a stock keeping unit, and you expect it to be unique for every single product. You would want to ensure that there are not duplicates. This can also be a result of replication, but it could even be at the application level where it's just a product is entered and you have this duplicate value. And this can impact product listings. It can impact sales. It can impact a lot. So uniqueness is another thing that's important to validate when you have primary keys, for example, and you're replicating that data to a system that doesn't necessarily enforce those primary keys. Nice. So we talked about data quality, what it is, why it's important, and we talked about the six dimensions that you can use to start to build rules for data validation. And now we'll talk about some tools and technologies that you can use to start to enforce this. There are a lot of really great validation frameworks out there. This is just a subset. Soda.io is one. Great Expectations is another. If you're in the Apache Spark world, Amazon's DQ is really good. And many of you are probably familiar with DBT data tests. When you're building your models and you have this transformation layer, writing your tests in your YAML alongside your models is really great. And then we have our Dagster Asset Checks. And this is a check on an asset that you can use to verify that your pipeline is operating correctly and the data asset is what is expected. And we'll go through some code examples later. But with Dagster Asset Checks, you can actually use the validation frameworks like Great Expectations and Soda. So it's really powerful. One kind of theme here, and I kind of alluded to this earlier, but this validation should really occur at all stages of the data life cycle. So say ETL, for example, say you're ingesting data from an API, you would want to ensure that that response is accurate to the structure that you would expect to get from the API. Say you're transforming that and storing it somewhere, you would want to validate the transformations. You would want to validate that things have been stored correctly, and if it's being replicated somewhere, validate that too. And then also, like your BI tools, say you're using Looker for dashboards. Something that we're exploring a little bit more in Dagster recently is having external assets to represent these BI tools, and then that would also be enveloped in this picture, and you could add validations on top of that. So you really want to have confidence in your data throughout. And that also is really helpful in that you could identify like where problems arise if you have validation at each step. So one thing when we start talking about having validation at each step of the data lifecycle, it becomes clear that the orchestrator is the natural home for enforcing this data quality. So it encompasses all the stages of the data lifecycle, and then you can start to make your systems more robust. So you can have conditional execution logic for your pipelines if data quality validations are failing. And also it can act as the single pane of glass for the health of all of the assets in your organization. So you can set up alerts, and you can also kind of have like a landing page where you can see the health of your assets. And a really important thing here, I think, is If you have a data platform owner, if your team's large enough to support that, this platform owner can start to enforce these standards for your pipelines and enforce like data quality. So like, for example, if you're contributing a new asset, maybe your data platform owner would enforce that you need to have an asset check on that. Or if your platform owner is abstracting away your pipelines into some YAML configuration language, they could also include asset checks on every single asset just by default. So it depends on how your data platform owner has set things up, but they can start to enforce these standards alongside with the data governance team. This is just a screenshot of Dagster looking at the global asset lineage. And I just wanted to show that here we're showing that we have raw data coming in, we're cleaning it up, we're doing some analytics on it, and we're doing some forecasting. And you can kind of get a good idea of the health of these assets just by the color of them. And when you start to add more and more asset checks, you'll have little green check marks by them. And we also have an asset health dashboard that we'll show a little bit later. Nice. So let's actually start looking at some code. So we'll start with the most simple example of writing a Dagster asset check. And these are code-defined expectations for the data produced by your pipeline, or for example, a data contract. And they run after the materialization of your asset, unless you trigger them manually or some other way. But it really ensures the quality of the asset that you're writing. So here's a basic example. We're first defining an asset. And in this asset, we're just mocking a pandas data frame. But you could imagine this could be a query to some API, and we're writing that to a CSV. We want to validate that that CSV has the correct data. So what we do is we use the asset check decorator. And as a parameter, we can pass in that orders asset that we defined previously. And here we'll just read the CSV and we'll do some pandas operations on the order ID column to see if there are any null values, and we'll take the sum of that. And then we'll return an asset check result with a passed condition. And this passed condition is just a Boolean of whether or not this asset check has passed. So in this case, we're saying the number of null order IDs is 0. We don't want to have any null order IDs. And then when we register our assets and our asset checks, we just do that on the definitions object. So that was a really basic example, but I think you could start to imagine how that could be extrapolated and you could start applying more rules. This is how it is represented in the UI. So on our asset, you can see there's a little checkbox in the bottom right. And when you click on that, you can get an idea of the asset check, and you can see the history of runs along with some plots of that history. But looking at that asset check code, you might be thinking, that was a lot of code for just checking if they're null IDs, and you might not want to do that. So you don't want to write all those validation rules. And the good news is you can use those validation frameworks that we mentioned previously. So we've recently published this blog post called Enabling Data Quality with Dagster and Great Expectations with the help of Mohammed. And I think it's a really great post to show you the power of Dagster asset checks alongside Great Expectations. So we'll walk through an example of that code now. You don't have to fully understand everything that's going on in this. There's a lot of like great expectations concepts, but the gist of it is we're defining a great expectations resource, and it just has one method on it. It has this get validator, and it takes in a pandas data frame, just like how we were operating with pandas data frames before, and it's returning a validator object. And this validator object will allow us to start chaining these validation rules on that pandas data frame. So again, we're just defining this get validator method and returning a great expectations validator object. It's this ephemeral validator, but great expectation has a lot of other features where it can like show up in their UI and be tracked. But this is just like an in-memory validation within our asset check. So let's look at how we would use that. In this case, we're not just going to do a single asset check. We're going to do a multi-asset check. And that means we could have a check with multiple validations for a single asset or multiple validations for multiple assets. So we're passing in these asset check specifications. We give it the asset that we're targeting, and we're giving it a name. So we're going to check that the target has no nulls and the target has valid values. Then in the method of that multi-asset check, we pass in that custom great expectations resource that we're just showing. And we read in the CSV that was produced by our asset. So in this case, it's this Titanic.csv, and we use our resource to get the validator object. And now we can use that validator to start to define these rules of how we want to validate our pandas data frame. So just like our first asset check example, we're going to check that the column values are not null. And we're going to say we want the column that's named survived to not have any null values. And then we yield an asset check result. And our past condition is the validation result dot success. And then we can also include some metadata from our validator object. So we include the validation result dot result, and that'll show up in the UI. So this time we're not writing like custom Python code. We're just using this expect column values to not be null validation rule that is a part of Great Expectations. Let's say we want to include another validation. Here's one where it's expected column values to be in a set. So this is that categorical validity dimension. So we want to say that that survived column can either have values of 0 or 1. And again, we just yield this asset check result. And in the blog post, we actually go one step further and we start to refactor this so that you can just pass in a list of rules and columns and the expected values. But I wanted to show the full example of how you can start to just declare one after the other. But this can be abstracted away to be even easier to use if you wanted to. And the blog post goes into detail on that. When you look at that in the UI, so we've clicked the Titanic asset and we've gone to the checks tab, and now we can see those two validations. We have the has no nulls and has valid rules. And then we can see the metadata from the result object that's being returned, and also some plots of this asset check for how it has run over time. So that was great. That was how you can start to use Dagster Asset Checks if you have more like Pythonic validation. But a lot of people are already doing validation on their DBT models using DBT tests. And if we want to start to expose that in the Dagster UI and make the Dagster, like the orchestrator, the home for all validation, we would want that to be propagated and shown there too. And the good news is our engineers have actually made it so that that just works. So you define your DBT tests as you would normally, and they actually show up in the UI as a Dagster asset check. So you might be familiar with this. This is just a DBT model called course reviews. And we have 3 columns, and we're just defining a few tests on each column. So this course review ID, we're saying we want it to be unique and not null. For course ID, we want it to have a valid reference to the courses table on that course ID column. And same thing with user ID. We want it to have a valid reference to the users table on the user ID column. That's just in your YAML spec, and it's just how you would naturally do it in DBT. DBT unit tests are also supported, but I didn't provide an example of that. But when you go to the UI, this is actually our Dagster University course, and you can see it's been running. We have the last 90 days of updates, and we have those 3 validations that are running through DBT tests as asset checks. So you can see all of those checks have succeeded, and they propagate and are visible in the Dagster UI. Nice. So what we were showing was how you would kind of define validation rules on your assets that are kind of aligned with the execution of that asset. Like you'll load some data and you'll validate that it's correct. But sometimes you want to have like an asynchronous check on the freshness of your data. And this is what I was alluding to in the very beginning when we were talking about the timeliness dimension. Sometimes you want to have this external process that's like pulling your data or looking at your asset materializations and validating that things have been updated in the last 15 minutes or so. So Dagster has freshness checks for that. And that's a way to define a contract around or SLA for your data freshness. And this is really good for identifying problems that other asset checks might not find. So for example, say you never turned on a sensor and your asset's never materializing. If the check's not running, you're not going to be notified of that failure. So having this external process that's checking the freshness of that asset can be really helpful. Or for example, say you have a run queue backed up and it's still processing yesterday's data. You can have a process that will validate that the data is up to date. And then downstream assets can reference this freshness check on the parent asset to determine if they need to run. So if a parent has up-to-date data, then like the child assets can then materialize. Here's an example of how to implement freshness checks. And thankfully, we have some helper methods to do it for us. So we can just call this build last update freshness check method. We can pass it in a list of assets, and then we can just give it a time delta of how often that needs to be updated. So from like the sensor evaluation, every 15 minutes, we would expect to see new data for these assets. And as before, you would want to have the asset check definition, which is the result of this method. But then we would want to have a sensor that's pulling for this asset check. So then we have a helper method called build sensor for freshness check. We give it our freshness or our asset check definition, and we can register those on our definitions object. So this is how that's rendered in the UI. So we have this freshness check, and you can see that we have execution history of it validating the asset materializations that they're occurring within that 15-minute window that we would expect. Here's just another example of freshness checks, but this time we're saying from 9 a.m. UTC, we would want data fresh within 3 hours, whereas before it was just pulling it every 15 minutes. This is more along the lines of, say you have a dashboard or some data that needs to be referenced at like in the morning by your business team. You can set up a freshness check to ensure that that data is up to date so that they can reference accurate metrics. And previously with the freshness checks, we kind of had an idea of what was considered fresh data, but sometimes that's not the case. So Dagster Plus Pro users can actually take advantage of anomaly detection, which actually runs a model and references the past materializations of an asset, and it can look for outliers or anomalies, and this asset check can fail accordingly, and you can set up alerts to detect if some unusual behavior is occurring. So this is a really cool feature. So once you start implementing these validations and these asset checks across your assets in your organization, and Dagster is kind of like this single pane of glass to overlook all of these assets, then you can start to reference things like the asset health dashboard to get a overview of the healthiness of your assets and your data. So this is just a quick screenshot, but you can see asset execution failures, you can see asset check failures, really a high level overview of everything that's going on in your Dagster instance and whether or not there have been failures. I often find myself referencing this like first thing Monday morning after a weekend just to see the health of things. Cool. So we talked about how to start to implement these validators and this how to enforce this data quality in technically in code, but there's more to that where it has to be promoted as a standard in your organization. And this kind of depends on the size of your organization and how many people are involved. But to really enforce this and have good guidelines, it needs to be enforced by like platform owners and governance teams. So you need to start to establish frameworks that promote this high data quality and validation. And you want to work with the domain experts in your company. So people who are highly involved in like the creation of some data, it's often really helpful to go to them and say, I need to write some validation rules on this data. Can we define some guidelines and work hand in hand until you can really ensure that the data is accurate? And then in general, it's good to start to foster this data aware culture within an organization. So your data engineers should be data aware, of course, but also it's great when your stakeholders start like looking at the dashboards and have an understanding of what is good data. And there's just like a collaboration amongst teams to establish these standards. And that being said, it's not easy. There are a lot of pitfalls and challenges with enforcing high quality data within an organization. And some of these are like managing data quality across distributed teams. Some teams might not want to enforce the same set of standards that your team does. I think in an ideal world, your like data platform owner will establish these standards across teams, but for larger organizations, there may be multiple data platform owners and multiple data teams. It's also difficult when dealing with legacy systems. Maybe that subject matter expert who you'd want to ask a question left 20 years ago, and you still have this Microsoft SQL database that's just still being updated, and you need to ingest that for analysis, and you have no idea what is good data. So that's tough. And then there's also a pretty significant upfront developer cost. When you think about application development and writing unit tests for your code, sometimes those unit tests can take like 75% of the time of developing. And it's similar with enforcing data validation. So it's nice to allocate enough bandwidth upfront to be able to complete like data validations alongside your data pipelines that you're building. And then finally, it can also be really tricky just establishing the ownership of data. If individuals are held responsible for the quality of their data, that works really well. But sometimes that enforcement, like an engineer will just finish a pipeline and kind of like throw that over the fence, and it's up to whoever to manage it. But like actually establishing the ownership of the data is really important and difficult to do. So in conclusion, we talked about a few things. First, we talked about what is data quality, why it's important, and kind of the most important thing is that enforcing high levels of data quality promotes trust in an organization. We talked about 6 dimensions to consider when building data validation rules. We talked about how the orchestrator is a natural home for this validation because it can act as like the single pane of glass over all of your pipelines and the health of your assets. And then finally, we kind of talked about how enforcing these standards is a team effort. You want to have everybody involved, and the platform owner, governance team, your data engineers, your stakeholders, everybody should really be working together to build this environment where it's possible to enforce high standards for data quality. Let's see. And next steps, yeah, we would love it if you gave Dagster a shot. So download Dagster, give it a try. If you have any questions, you're welcome to reference our blog post. Like that Great Expectations blog post from earlier is a great read. And also, if you have questions, you can chat with us on GitHub discussions, on Slack. We have an Ask AI channel that we've trained on our blog posts and documentation that actually does a really fantastic job of answering questions. And then tune in for the next deep dive. I think August 22nd or later on, we're going to be having another one of these on using SDF with Dagster, which I think will be really exciting. Great, that's all I have. Questions, anybody?
Yeah, a lot of questions came in via the
Wow.
Q&A. Do you want to take a couple of those?
Yeah, sure. And maybe Pedram can help out a little bit. Let's see.
Yeah.
Yeah.
So the first question is, could you please distinguish between Dagster and Dagster Plus, where one provides mentioned features and the other does not? Yeah, so Dagster Plus has a few other features like the anomaly detection, for example, and insights. Most of the core features of Dagster are available in open source, but there are some distinguishing features that we are pushing to Dagster Plus, and the full comparison of those features, I believe, is on our website. See, the next question is if an asset check runs after materialization and fails, does that mean we're producing invalid, unhealthy, or broken data? Yeah, that's a good question. So to your point, like if you were to have an asset that produces a CSV and the data is invalid and the asset check is failing, that is an indicator that that data is broken. So you would want to structure your pipelines in such a way that like downstream execution stops there, and then you can go back and figure out what's failing, and then you can fix your pipeline accordingly. That's right. Let's see. Is asset health only for Dagster Plus? Do you know that, Pedram? If the asset health
Yeah.
dashboard?
I do. The asset health is only for Dagster Plus, and it includes things just beside asset check. So there's a question on one version. It's available. Really, any Dagster version would work as long as you're on Dagster Plus.
Great. Let's see. Next one. If I have DBT assets and the data lives in a DBT managed Postgres, how to include great expectation based checks that include multiple columns with Dagster checks? Loading the table from Postgres using IO Manager first. So you have DBT assets. Let's see, DBT managed Postgres, and you want to have great expectation checks on those columns.
I would probably find the SQL query that generates a table and then pull that in like a pandas data frame is if you're using Great Expectations. I haven't used Great Expectations too much, so I'm not 100% sure, but if it operates on a data frame, then I think pulling the data into a data frame and running it that way might work.
Yeah, I also don't have the most experience with Great Expectations other than the demo we gave today of working on pandas data frames, but it may have a way to target a table out of the box. I'm not sure. That's something that would be in the Great Expectations documentation. But you could totally just define an asset check or a multi-asset check and operate on it that way.
Someone's asking if there's an open source repo which is showing all these advanced features in use. I think the answer is yes. Is that right?
So the slide deck is included in our talks repo. A lot of these examples were taken from our documentation and the Great Expectations blog post. And then another great reference is our Dagster Open Platform repo. So the actual code of this talk is just in the slide in our talks repo, but our Dagster Open Platform is also a pretty good reference.
Awesome. I just shared that as well in the chat. There's so many questions here.
Yeah, this person said the data governance rules should never be owned by the data pipeline engineers. Yeah, that's not something that I recommended in this talk. It was something more where it's a team effort. So you have your data platform owner, your data governance team, and they're establishing the rules that your engineers would have to enforce. So it's more of like an overarching guidelines that the governance team works on. But I agree that, yeah, it shouldn't be owned by the engineers, but I think it is a team effort and everybody should be involved. Oh, there's a lot of questions. I might have to start just picking.
There's a
Yeah,
question
why don't we take a couple more, guys? Just a couple more, and then whatever we're not able to answer today, we can follow up as well. Does that sound okay?
Yeah.
Yeah, that sounds great.
Great.
Do you want to take one, Pedram?
Yeah. Justin's asking, what is the recommended best practice for organizing these asset checks? Should it live in the same file as where the asset is defined or in a separate parent directory? I think I like having them in the same file. I think organizing things together by like, the pipeline you're having makes a lot more sense, and it's just easier to know where to look. If you have so many asset checks that, it becomes too much for a single file, then maybe in a separate directory would make sense. But I tend to like to have everything that's like compartmentalized together from my resources, my assets, a job schedule, and the asset check together in the same directory. Just a little simpler that way.
Yep. Morton asked, can I set up my own alerts for asset check results? That is possible. You would want to set up your own sensor monitoring the asset checks, and you could select a subset or all asset checks, and then you would trigger an alert within that sensor.
Awesome. So what I would suggest is if you still have questions that aren't answered, join us in our Slack channel, and you can come into maybe like community events and talk to us there, and we'll be there for the next like 20 minutes answering some more questions.
Sounds great. Thanks so much, everyone, for attending. Yeah, and I look forward to future communication and questions on our Slack.